Cape Canaveral, Florida. Atop this Atlas rocket is a spacecraft that will embark on a wondrous journey. And at the University of Colorado's Laboratory for Atmospheric and Space Physics, they're celebrating. For scientists and students here in Boulder, Colorado, this is their day, Launch Day. November 18th, 2013, when a piece of CU will blast off for Mars. Its mission? To find out what happened to all that Martian water. The Mars Atmosphere and Volatile Evolution spacecraft, or MAVEN, is the result of an incredible partnership between CU, the University of Berkeley, Lockheed Martin, the Jet Propulsion Laboratory, and NASA's Goddard Space Flight Center. MAVEN hopes to answer that overarching question: did Mars ever have life? Welcome to this edition of CU Science Update. I'm Alexandra Pash. MAVEN is the first spacecraft of its kind devoted to exploring the upper Martian atmosphere. By measuring the current rate of the atmosphere's escape to space, MAVEN will determine how much of it has been lost over time. Calculating backwards, we might learn whether Mars had a climate that could have supported life. Millions of years ago, Mars may have once looked like Earth, with a thick atmosphere and oceans, and a surface more suitable for microbial life. But something happened that caused Mars to lose much of its atmosphere, leaving the planet cold, dry, and inhospitable. Brian Henick, an assistant professor in the Department of Geological Sciences at CU, believes that this new data could change our perceptions of the red planet.
The answers that MAVEN will provide really will help constrain what the early atmosphere and climate were like at Mars and how it was lost through what different processes through time. So that certainly plays into our different approach of looking at the geology to try to understand the past climate. So hopefully we'll be able to reconcile the data from MAVEN with what we think happened given the surface geology. You know, we have a lot of ideas about Mars. It's really hard to understand when things happen though, because we don't have rocks that we can go out and get age dates for like we can on Earth to really understand when these river valleys were active, when the deltas were forming, when the volcanoes were active. So we use models to try to understand, and the models are based on the impact craters and how many craters are on the surface. But yeah, we have a lot of questions in terms of when these things happen, and hopefully MAVEN will start to answer those questions. The MAVEN mission that's about to launch to Mars is really looking at those processes in how the atmosphere evolved, how the atmosphere was lost. So that'll really play in to our understanding of the planet, and it'll be measuring how quickly it's being lost by various processes, and then be able to calculate back in time what it must have looked like in the past.
MAVEN is gearing up to solve this great mystery, and maybe help us learn more about climate change back on Earth. Today is the first day for a launch window, when the orbits of Earth and Mars align exactly right. That window will last only 20 days. If MAVEN misses it, the launch will have to wait 2 more years before Earth and Mars are in the right positions again. But if all goes well today, MAVEN will reach Mars in September 2014, and then the science really begins. CU Science Update reporter Scott Oberto met with Nick Schneider, an assistant professor in the astrophysical and planetary sciences here at CU. He is also the lead scientist who developed one of the remote sensing instruments on board the spacecraft.
Ancient seabeds, dry river basins, pebbly sandstones deposited across the surface. There's a flood of evidence that long ago water once flowed on Mars. Now it's just a lifeless desert. We've sent rovers to Mars, or orbited the planet with probes that have collected amazing data and detailed surveys. These other missions established that there is still water on Martian soil, some absorbed or frozen. But there is still another possibility. The water might have evaporated to outer space. Packed with sophisticated remote sensing instruments, MAVEN will hope to confirm whether Mars was once like Earth.
I think that's just about the biggest question we can be exploring. Is it possible that Mars was habitable? That's the first question, and then look deeper. Could there have been life there?
Professor Nick Schneider is a researcher in the Laboratory for Atmospheric and Space Physics. He describes the suite of instruments on board MAVEN as not being unlike human senses.
These antennas are like the ears of the spacecraft, and they actually can listen to the electric and magnetic fields and waves. We've got other instruments on board that can basically measure the local environment, the gases and charged particles. Those are like the nose of the spacecraft. And our instrument, the imaging ultraviolet spectrograph, you can guess from the name, is like the eyes.
Professor Schneider heads the instrument team for the IUVS, which allows MAVEN to study Mars at a distance by analyzing the light it emits.
The imaging ultraviolet spectrograph is this gadget right here. It's a $20 million box that can look at the atmosphere of Mars, which glows in ultraviolet wavelengths.
Although the human eye can't detect ultraviolet light, the IUVS can. It works like a prism, separating the colors that reveal what gases are present in the atmosphere. The IUVS will also infer the escape rates of hydrogen and oxygen in the upper atmosphere, providing important insights into how the Martian atmosphere has changed over time. Built at LASP, the imaging ultraviolet spectrograph is what makes the MAVEN mission so special.
So we think the imaging ultraviolet spectrograph on MAVEN is the most powerful spectrograph ever sent to another planet.
And now, thousands of hours of work all comes down to the final moments before launch.
I'll be in the bleachers with everybody else, just heart pounding.
MAVEN's instruments will work in concert to find out what led to the loss of Mars' atmosphere, building a better global understanding of the red planet. Reporting for CU Science Update, I'm Scott Oberto.
The MAVEN science team includes dozens of people from around the country. But the science will be coordinated here at the Laboratory for Atmospheric and Space Physics. For some, the mission began years ago. But for principal investigator and scientist Bruce Jakosky, getting to launch day has been a decade-long journey. A CU professor of geological sciences and director for the Center of Astrobiology, Jakosky developed the MAVEN concept. His tireless commitment and passion convinced NASA to award CU Boulder the project. It's all come to this moment. Launch day has finally arrived. For the last 4 months, Jakosky has been in Florida, getting the spacecraft prepped to ensure it was ready for the 10-month-long voyage to the Red Planet. But back in July, he was in Denver to unveil MAVEN to the media at the Lockheed Martin plant, where the spacecraft was assembled.
What we don't know in terms of the climate change is where did all the water go? Where did the CO2 go? What happened to it? It can either go down into the crust and be locked up there, or it can go up and be lost to space out the top of the atmosphere. MAVEN is designed to explore that latter possibility, to answer the question of, was the atmosphere lost to space, or is it still locked up somewhere on the planet?
To do this, the MAVEN spacecraft will be exploring the top of the atmosphere, where all the gas would have to pass as it escapes into space. The engineering team will control the spacecraft at Lockheed Martin's operations facility. But the science activities will be coordinated here by a team of scientists and students at CU's Laboratory for Atmospheric and Space Physics. Basically, CU is in charge of the MAVEN program. Guy Buedelschieß is the Lockheed Martin program manager for the MAVEN team that is responsible for designing, building, testing, and then, after launch, operating the spacecraft. He's also a CU alum. In the 1980s, Buedelschieß worked at LASP as an aerospace engineering major, where he actually got to operate a spacecraft called the Solar Mesosphere Explorer. It was the opportunity of a lifetime.
And you can't imagine being a kid who's dreaming of working on spacecraft, and then at 19 getting the opportunity to actually be a controller and actually be sending up commands to a spacecraft and then processing that science data and helping some of the leading scientists in the industry at CU process this data and pull out those science results. So it was a fantastic opportunity that I don't think I could have gotten anywhere else.
And quite an amazing opportunity. You look up at the stars and someday dream of visiting an alien world. But for the students at LASP, that dream is reality. CU Science Update reporter Caitlin Rockett met with students who are living their dreams.
As MAVEN begins its 10-month journey to Mars, students at LASP will get real-world experience unlike anywhere else.
There's very few places in the world that build missions, and LASP is one of them. I am working on the science that we will do once we get to Mars. We're going to bring back a lot of data, and we're going to have to analyze it in a very short amount of time.
And that data is what's going to help researchers understand what happened to all the water that once flowed on the surface of Mars.
When people look at images of the surface of Mars, they see these erosion features, and people think that it was liquid water that caused those.
Signs that there was once water in abundance means that Mars could have been much like Earth, with the potential for life.
Mars is an interesting example of a planet that, in some sense, failed to create life. I mean, if you view it from the point of view of an Earthling, Mars is not a very successful planet. MAVEN is dedicated to understanding that change, the transition from a warm and wet early Mars to the cool and dry Mars we see today.
And this is where the students come in. From its 8 sensing instruments, MAVEN will be sending massive amounts of data to Earth. This cracking team of students will help give the data meaning.
The instrument that I'm working on is it's called the Langmuir probe, and it's the 2 little bunny ears that point out from the spacecraft when you see a model of it. And so that looks at the density of the atmosphere.
Another instrument built by LASP is helping student researchers see what our own eyes can't.
The instrument that I work on is a remote sensing instrument called the Imaging Ultraviolet Spectrometer, which is basically a special camera that is able to spread out the colors of light that we see from Mars in the ultraviolet region of the spectrum, which is the region that's bluer, more energetic than the light that we see with our eyes.
Different elements, like hydrogen, create different colors. By looking at how atmospheric colors change over time, researchers can understand how the atmosphere has changed.
I look at the hydrogen air glow, hydrogen atoms in the upper atmosphere of Mars that are scattering sunlight. By looking at the intensity of that air glow and its distribution, we can tell how much hydrogen is leaving Mars today.
All of this information seeks to answer that one important question. Was there ever life on Mars? And if so, what will that mean for us here on Earth?
If we find life on Mars, that indicates that life is common in the universe. 2 planets that both developed life independently in the same solar system, that means that life is common. If we don't find life on Mars, if Mars is a sterile planet, then that indicates that life is very precious.
Instead of learning about it in the classroom, these CU students at LASP are getting front row seats to our exploration of the red planet.
And there are a lot of students here at CU who are going to get a lot of really good work done on the data that comes back from MAVEN. We have a place here in a collection of scientists and engineers here that's pretty unique. And there are only a few other places in the world that are even capable of coordinating a mission like MAVEN, and LASP is one of them, so that's pretty sweet.
Reporting for CU Science Update, I'm Caitlin Rockett.
Over the years, CU's Laboratory for Atmospheric and Space Physics has opened its doors to countless students. In fact, this year, 2013, LASP is celebrating 65 years of space experience, which began with rockets like this that explored Earth's atmosphere. CU Science Update reporter Nick Altieri met with a systems engineer who has been with LASP for over 30 years. He tells us that MAVEN is just the latest in a long list of space missions that involved LASP.
Richard Conert has been a systems engineer at LASP for 30 years. His mentor was one of the original directors of the lab when it began shortly after World War II.
So the U.S. recovered a bunch of V2 parts and rocket parts from Germany. What the government learned was that it wasn't industry that was making these rockets, it was the university scientists and whatnot.
The U.S. government saw the value in developing rockets, and they tried to get universities involved by offering certain incentives.
They would have the university scientists engaged by offering them rides for their experiments into space.
LASP started out in 1948 by a team of CU Boulder physicists. Their first project was a biaxial pointing control system, which helped stabilize rockets from spinning excessively.
The initial name of the laboratory was the Upper Air Laboratory, the UAL, and its primary objective at that point in time, besides developing the pointing controls, scientifically was to determine the extent of the atmosphere.
In 1965, the Upper Air Laboratory began planetary research and took the name we know today. In 1967, CU's Laboratory for Atmospheric and Space Physics sent instruments on board NASA's Mariner 5 to Venus. Its mission? To measure the magnetic field, pressure, and temperature of Earth's sister planet. But it was in 1969 when LASP first went to Mars. Back then, the lab built the ultraviolet spectrometers that were carried by Mariners 6 and 7, which made flybys of the red planet.
The primary goals of the Mariner flybys were simply to determine whether or not Mars had an atmosphere and some of the constituents of the atmosphere.
What the Mariner mission showed is that Mars does indeed have an atmosphere, composed mostly of carbon dioxide. There were more space missions to come. Starting in the 1970s, LASP assisted NASA's Voyager missions, exploring the outer solar system, and recently, with the Kepler spacecraft, taking surveys of stars to find exoplanets that orbit their parent stars in what is called the habitable zone, where a planet can be capable of sustaining liquid water. Finally, there's the unique story of LASP students who built an instrument that was launched in 2006 for Pluto. The Venetia Burney Student Dust Counter is an instrument on board NASA's New Horizons spacecraft. It will reach Pluto in 2015, but in 2010, the Student Dust Counter became the record holder for the most distant functioning space dust detector ever in space. Despite these missions to the far reaches of our solar system, LASP scientists and engineers are still drawn to the red planet. MAVEN is perhaps their most ambitious project. But before it can find out why Mars lost most of its atmosphere, MAVEN first has to get there. Designed and built in Colorado, flown to the Kennedy Space Center in Florida, and now poised for launch atop an Atlas rocket, scientists and engineers are making sure that MAVEN will leave Earth without a hitch. Reporting for CU Science Update, I'm Nick Altieri.
While MAVEN is set to leave Earth and keep a lot of scientists and engineers busy, Launch Day is also special for the next generation. CU Science Update reporter Erica Jackson tells us how one kindergarten class in Boulder became more than just onlookers.
5, 4, 3, 2, 1, launch!
Boulder has a strong history of starting its kids off early with space education. Launching model rockets is one way to fuel the imagination. But another is through art. And for these kids, their art is about to be launched to Mars.
I'm Jill Williams, kindergarten enrichment specialist at Crestview Elementary, and I'm with my former class from last year that are now in first grade. I found out about CU having this art competition, and I just thought, what a great local opportunity to become involved in.
These students from Boulder's Crestview Elementary are the winners of an international art competition, the MAVEN Going to Mars Student Art Contest. The 15 students won with over 9,000 votes in the worldwide public voting contest. Their winning art was the only three-dimensional art submitted.
Because all of the other guys just did pictures on the computer, but we actually did a project.
The students created their own Mars planets out of paper mache, complete with art that shows what they'd bring along on a trip to Mars.
Well, me and we put on some sun because it's really dark and it's very cold on Mars. So we put a sun on, and A put some water on because we need it to help ourselves and drink it. Well, I know I put on a flag.
Why? Why did you put a flag on it?
Well, because It's important.
Their artwork will appear on the outside of a DVD that will feature the other 376 artwork entries. The DVD will then be attached to the MAVEN spacecraft.
The whole classroom was just like, yay, yay!
For these space artists, today is special. They've been invited to the University of Colorado for a day of science and space education fun with CU SEDS, students for the exploration and development of space. Crestview Elementary teacher Jill Williams is all about giving her students the opportunities they need.
In my classroom, I have an art studio. So I had 2 children that were just randomly in the art studio playing with Play-Doh, and they were rolling it in their hands in little balls, and more friends were coming over and asking, well, what are you doing? Can we help you? And before I knew it, I had a classroom planetarium started. So in unspoken words, the class was leading me to say, we really are curious about space.
Today, the kids are prepping for that special day. They're learning about propulsion and talking to astronauts.
Joe Tanner and I had lunch with first graders today. They thought of it as lunch with an astronaut. They had a first grade class from Crestview Elementary. They came here to tour the labs here at the University of Colorado Aerospace Department and College of Engineering, and they got to see some really interesting things. I think what got their most attention were rocket launches, which they liked a lot. But we had lunch with them and they asked questions and we talked to them about space, and they seemed pretty excited about their day here.
Now, as the countdown commences, these kids can hardly contain their excitement over their newly acquired knowledge on the red planet.
We dig deep enough, people think this. If they'll say if we dig deep enough, we'll find water, so they're setting up MAVEN to orbit Mars to see why the water went down. MAVEN and Mars, Mars is red. It's the 4th planet in the solar system, and it's really rich in iron. Because I'm gonna try to be the first one. Try. Me too.
To do what?
To go to Mars.
Science is like a story that hasn't been written yet. But this experience, it definitely puts some words on the page in our journey.
Reporting for CU Science Update, I'm Erica Jackson.
This is it, the moment we've been waiting for.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, ignition, and liftoff of the Atlas V with MAVEN, looking for clues about the evolution of Mars through its atmosphere.
Everything looking good, still at 100% rated thrust on the RD-180. Vehicle rates are looking good. We do have roll program in, right as expected. They are actively controlling.
Launching a rocket is one of the most unique experiences anyone has ever witnessed. It's one thing being there in person, but another to share the experience with others.
Continue down the center of the range track. Everything is looking good.
MAVEN is on its way, set to enter orbit around Mars in September 2014.
0.1 miles downrange, operated.
For a year after that, the spacecraft will make the first direct measurements of the Martian atmosphere.
And vehicles passing through max Q, rates look good.
We know that Mars once possessed liquid water, rivers and oceans of it. From that chemistry, did life arise? If so, then that would tell us that life is not unique to Earth. If we find out that life once existed on Mars, then that means life could be flourishing elsewhere in the universe. A single spacecraft might not tell us everything that we want to know, but MAVEN has the potential to unlock some of those famous Martian mysteries and forever change our view of the red planet. For CU Science Update, I'm Alexandra Pash.